Hello, welcome back to the night class. Hope everyone is doing well out there. I'm Coach Knight, and today's lesson we're going to talk about nonlinear inequalities and their graphs. I got 4 examples here that I use in my Advanced Math Plus class, and hopefully they help you understand how to do these a little more. So our first example, we just have 1, 2, 3, 4 points, and they're asking, are they solutions to the inequality y is less than or equal to x minus 2 squared minus 3. So to figure that out, we plug in the points one at a time. I'm going to plug in -3, -4. That's my x and that's my y. We plug them into the inequality. So -4 is less than or equal to 3 minus 2 squared minus 3. And you simplify both sides. That will be 1 squared minus 3, which is -4 is less than or equal to -2. That is true. Therefore, -3 or 3 -4 is a solution to that inequality. And then we try another point. So the next point is 4, 7. So again, plugging in just like we did, 7 is less than or equal to 4 minus 2 squared minus 3. That will be 7 is less than or equal to 2 squared minus 3. 7 is less than or equal to 1. 2 squared would be 4. 4 minus 3 is 1. 7 is not less than or equal to 1, so 4, 7 is a no. It is not a solution. The next point is 1, 1. Plug it in. There's my x, there's my y. So 1 is less than or equal to 1 minus 2 squared minus 3. 1 is less than or equal to -1 squared minus 3. 1 is less than or equal to -2, because -1 squared would be +1, and 1 minus 3 is -2. Last time I checked, 1 is not less than or equal to -2, so that is also a no. And our last point that we're checking, -1, 6. Again, -1 is my x, 6 is my y. Plug them in. 6 is less than or equal to -1 minus 2 squared minus 3. 6 is less than or equal to, that'll be -3 squared minus 3, which is, let's see here, that would be 9 minus 3. 6 is less than or equal to 6. It's not less than 6, but it is equal to 6. So this one works. So it is a yes. So 3 -4 is a solution, and -1, 6 is a solution. 4, 7, and 1, 1 would not be solutions. Our next example, we are just graphing. Looks like we're graphing a cubic here. It is an inequality because it says greater than or equal to x minus 4 cubed minus 2. So to graph cubics, you make a table of values. I know different teachers have different methods. I always like starting with whatever makes the parentheses 0. So in this case, if I was making the parentheses 0, I would plug in 4, because 4 minus 4 is 0. 0 cubed is still 0. 0 minus 2 would be -2. And then I just plug in some numbers on either side of 4. So 3 would be on the left side of 4. If I plug 3 in, that's -1. -1 cubed is -1. Minus 2 would be -3. 1 to the right of 4 would be 5. 5 minus 4 is 1. 1 cubed is 1. 1 minus 2 is -1. And then let's do 2 more. So 2 to the left of 4 would be 2. If I plug in 2, again, I'm just plugging in up here and doing it in my head, okay? So 2 minus 4 is -2. -2 cubed minus 2. -2 cubed is -8. Minus 2 would be -10. And then the last one, 2 to the right of 4, would be 6. So if I plug in 6, 6 minus 4 cubed minus 2, that's 2 cubed is 8. 8 minus 2 is 6. So 6, 6. All right, and then after you do that, you graph it. So we're going to have 4, 1, 2, 3, 4, down 2, 1, 2. There's our first point. Let me do this in red so it shows up a little better. There we go. There's our first point. 3, negative 3 is our next point. 5, negative 1. 2, negative 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so all the way down here at the bottom. And then 6, 6. 2, 3, 4, 5, 6. And all cubics make this little kind of curly, it kind of comes and does a little thing and then keeps going down really fast, basically. Now, notice I drew a solid line, okay, not a dashed line or dotted line or however you like to refer to it. It's a solid line because it was also equal to. And then for the shading part, basically I put my pen or pencil on the graph in the middle, and if it's greater than, I go up, and if it's less than, I go down. So this is greater than, so I'm going to shade everything above it. Excuse while I shade, it's not very pretty, but that would be your inequality. Remember, anytime you have an inequality, there's going to be shading involved when you're talking about graphing it, okay? So everything above this line works. Example 3, another graphing one. This time we're graphing a absolute value. Same thing, I'm going to make me an XY chart. We're going to see what makes, in this case, I'm going to try to make the absolute value 0. Again, this is just how I do it. That would be negative 2, and if you plug that in, you get 3 for y. If you plug in negative 2 for x, negative 2 plus 2 is 0, and then you're left with 3. So it's real nice and quick. Again, I'm going to take and plug in 1 point to the left, 1 point to the right, and then 2 points to the left, 2 points to the right. So 1 point to the left of negative 2 is negative 3. If I plug that in, I will get 2. I get 3 minus 1, which is 2. If I go 1 to the right, would be negative 1. I also get 3 minus 1, which is 2. Do one more on each side. 2 to the left of negative 2 is 0. If I plug that in, I'll get 1. 3 minus 2 is 1. And then last but not least, 2 to the right of 2 to the left, 2 to the left of negative 2 would be negative 4. If I plug that in, I also get 1. And then you plug in your answers. So negative 2, 3, negative 3, 2, negative 1, 2, 0, 1, negative 4, 1. And as you see, since it's an absolute value, their graphs always make an A or a V. All right, and so I am going to graph these. Now notice, it's just greater than on this one. So I am going to do a dashed line for my graph. And I'm going to, again, it's greater than, so I'm going to shade everything above it. So everything above my graph. If you keep it simple like that, it's hard to mess up. Just remember, greater than you shade up, less than you shade down, no matter what type of equation you're talking about. All right. For our fourth and final example, I forgot to write it. So let's see what example 4 was. Excuse me. Example 4, absolute value of x minus 2 minus 5 is less than 4. The absolute value of x minus 2 minus 5 is less than 4. So this one, you notice we do not have a y. It's just an x. So we're going to actually graph this on a coordinate plane, or on a number line. So if I add 5 to both sides, you always want the absolute value to be by itself. And now I have a little rhyme to remember. If it's less than, it's and. If it's greater than, it's or. Okay, so less than equals an and. Greater than equals an or. Okay, so you make two equations because this absolute value inside it, well, it could be 9 or it could be negative 9. So you have to make two equations. So x minus 2 is less than 9. And since it's a less than, it's going to be an and. X minus 2 is greater than negative 9. You change the 9. It has to be less than 9 and greater than negative 9. And then you work both of them out. So add 2 to both sides. X is less than 11. And if I add 2 to this side, x is greater than negative 7. And then most teachers want you to write it in interval form. So you'll put the smallest number first. X has to be bigger than negative 7. So you say x or negative 7 is less than or not equal to on this problem. Sorry. Negative 7 is less than x, but it's less than, x is less than 11. So basically you're saying x has to come between those two numbers. And that's it. I hope these examples help you understand a little bit about nonlinear inequalities, and we'll see you next time. Stay above the line.